Right. Every routing protocol supports authentication. We have seen in EIGRP it supports only Md5 authentication. OSPF supports both clear text as well as Md5. So the routing protocol OSPF has got this both clear text and Md5. The problem with the clear text is they are not that safe, meaning someone may sniff a packet, OSPF packet, and know the password. I'm going to show you those things. They can know the password, but when you use Md5 authentication, only the hash values are going to be sent, not the clear text. So Md5 authentication is more safe than clear text authentication or the plain text authentication. OSPF has got authentication types saying null authentication, which is type 0, clear text authentication, which is type 1, and Md5 authentication, which is type 2. So not only the password, even the type should match between the routers. If I have two routers, we'll take two routers in our demo, same like this, like 10.0.0.1, 10.0.0.2, and let us take some loopbacks 1.1.1/32, 1.1.1.2/32, 1.1.1.3/32, 1.1.1.4/32, and this will be router 1 and router 2. Let's say 2.2.2.2/32, (2.2.2.1/32), 2.2.2.4/32. So we'll take some subnets like this and we'll run OSPF on both the routers. And now when you sniff a packet, you will see authentication type 0, meaning null authentication. That's type 0, no authentication. Later, we'll configure authentication. We'll configure type 1 on one side, meaning clear text authentication with a password, let's say Cisco 123. This will be the password, this will be the type. We'll enable OSPF authentication type 1 on one side. The other side, no authentication. We'll put some debug and we will see. What we will see there is, router 2 will say, I'm not able to form adjacency with router 1 because router 1 is sending me type 1 authentication, whereas we use type 0. That's the reason. It will show you very clearly when you debug. If it is type 1, what does it mean? Clear text. So router 2 will know that the router 1 is using clear text authentication. It knows even the type what the neighbor uses. Type 1 authentication. And router 2 will say, we are using locally type 0, meaning null authentication, so I cannot form neighbor. Now when I change this to type 1 by putting some password, same password, not some password, same password should be configured on this side. When I do that on both the side, the type matches as well as the password matches, and they form neighbor. After that, what we'll do is we'll enable Md5 authentication, just type 2. On this router, when we enable type 2 authentication, even though the password is same, they will not form neighbor. The reason is the type mismatches. Router 1 is sending a hash value. Router 2 don't understand it. because router 2 don't generate a hash because it uses type 1. So router 2 will not form adjacency. It will say we locally use type 1, whereas the neighbor incoming is type 2. So the type mismatches. Authentication type should match. So when I go here on router 2 and change to type 2, then the neighborship will come up and you will be able to ping. So OSPF supports 3 type of authentication, though this is not a type of authentication. That's how OSPF considers. Type 0, null authentication. Type 1, clear text authentication. Type 2, Md5 authentication. Message digest is the one which sends the hash value instead of sending clear text authentication. Any question? We're going to see the lab here. Do you have any question on this?
No, sir.
Right. Null authentication is no authentication at all. We have not configured any authentication. Simple OSPF. No. Just we enabled OSPF. That's all.
No password.
Yeah, no password, no authentication configuration is attempted. We have not tried configuring any authentication. We have just enabled OSPF. The default OSPF will have null type 0, means no authentication. Null means no authentication.
Got it.
So one side no authentication, the other side clear text, conform neighbor. Both the side the type should match. So one side MD5, other side clear text, that also cannot form neighbor. Even if the password matches, because the type mismatches, they cannot form neighbor. On router 1, loopback 0 has got 1.1.1.1. Interface loopback 1. 2 in the end. Loopback 2. 3 in the end. 3. 4 in the last octet. Done. And then on interface G1/0 we'll put IP address 10.12.0.1 24 actually, not 32. This should be 24 or 16. It can also be 16. Yeah. So we got the interfaces configured. Show IP interface brief. So this are the 4 interfaces on loopbacks with this IP address, and one physical interface 10.12.0.0.1. On router 2, one trace loopback 1. Let's put 2 here. Oh no, something is wrong. Okay, the mask is the problem. It should be 24 mask. Loopback 0. This should be 255. Loopback 1. 255. And then there won't be a conflict. 255. Done. We got the 3 loopbacks configured. Let's get into the key1/0 interface. Put the IP address 10.12.0.2. See, done. We got the IP address. Plain. Just the IP address configured. 3 loopbacks and 1 physical interface. Let's enable OSPF. On router 2, I'm going to configure OSPF under the interface like this. Interface G1/0 IP OSPF 1 area 0. On the loopbacks, I do the same. So I can use the range command, interface range loopback 0-2 IP OSPF 1 area 0. Now all these interfaces run OSPF. Let's verify. Show IP OSPF interface brief. This shows that 4 interfaces are running OSPF in area 0 under the process ID 1. On router 1, I'm going to enable OSPF. Let's use the classical way. Router OSPF 1 networks. I'm going to say any network that starts with 1 in the first octet. The other octets I don't care. Should be put inside area 0. Done. Which means all these 3 interfaces will be now running OSPF, because I've said only the first octet should be 1. The rest of the octets I don't care. That's what this means, 255. And then network 10, 12, 0, 1. We can also say like this. All 4 octets should be same. Now I'm expecting a neighbor between R1 and R2. The neighbor has come. The neighbor has come. Router 2 is identified with the biggest loopback interface address. That is what we learned, right? The router ID will be the biggest IP address from the loopback interface. That's what we see here. Router 2's biggest IP is 2.2.2.3. Likewise, router 1 will see, router 2 will see router 1 as 1.1.1.4 because that's the biggest IP on the interface. 1.1.1.1.4. If you see on router 1, show IP interface brief, we got 4 loopback interface. Let me add it here. Yeah. Fine. So we got now OSPF, and I should be able to see the routes. I can see 3 networks learned from router 2. This O stands for OSPF local area, type 1 and 2 LSAs. Show IP OSPF database. You see, through these advertisements, these 3 networks have come. We don't have any other area, so you will have only LSA type 1 and LSA type 2, which we have learned earlier, LSA types. Alright, so I can ping now 2.2.2.2. I can also ping 2.2.2.3 with a source of 1.1.1.4. When I ping with 1.1.1.4, what does it mean? If the reply comes, what does this mean? Router 2 knows to reply to this source. Router 2 knows the route to reach my loopback 114. So I no need to go and check from there pinging this address. You no need to do that. Sorry. Instead of going to router 2 and pinging this address, I can ping from router 1 to router 2 to see the response. Right. We have reachability. Let us now enable authentication. By default, there is an authentication called Null Authentication that you can see by typing debug IP OSPF packets. If you see now carefully here, the authentication type is 0, means null authentication. Null authentication. Let me sniff some packet and show you. capture. Alright, I pick on OSPF packet, and this is the OSPF header, and you see authentication is type 0. See, null authentication, type 0 authentication, none, null authentication. Now let us go and enable type 1. I stop the debug. I'm enabling type 1 authentication. Configuration is easy. OSPF authentication configuration is very easy. Interface G1/0 IP OSPF authentication. That's the command. IP OSPF authentication type. Simply hit enter if you want clear text. If you want message digest, you select this. We want only clear text, so simply type IP OSPF authentication, which is going to be type 1. And then we say IP OSPF authentication -key. See, same command, just put hyphen without any space and key. Let's give the key Cisco 123. Done. On R1 we have enabled authentication. That simple it is. We go under the interface and we say we want to enable clear text authentication, not MD5. And we want to use this as the key. This is the password. Now we see the neighbor has expired. The neighbor has gone down. Now going back to this, click this. You can see now type 1 simple password. Type 1 authentication, type 1 simple password, and you can even see the password. See? This is not good, no? You can even see the password. Even here you see the hash value Cisco CISCO123. Simple password. Yeah. So on one side it is simple password. The other side, let me pick the other side. Other side null. Will they form neighbor? No, they will not form neighbor. We will not be able to ping anyone. Let's see. Show IP route OSPF, no routes. No routes. We lost the neighbor. Show IP OSPF neighbor, no neighbor. So if you want neighbor, we have to match with the authentication type and authentication string. Let's go to router 2. Interface G1/0 IP OSPF authentication, enter. So now the type is matched. Next is authentication key, Cisco 123. Now the key is also matched. I'm expecting neighbor. Look at this, neighbor has come up. Going back to the Wireshark, you can see now the authentication on router 2. This is router 2, 3. So it is router 2 whose authentication type is 1 and the password is Cisco 123. You can also see that by typing this debug command, debug IP packet, IP OSPF packet, you can see the authentication type mentioned here. Look at this. Authentication type is 1. Earlier it was 0. Now it is 1. Alright, so we have finished seeing type 0 and type 1. Now what I'm going to do is on router 1 I'm going to enable type 2. Type 2 is message digest. Very simple. Going under the interface, IP OSPF authentication message digest. Just one additional command. That's all. I'm expecting the neighbor to go down now. It will go down because one side is a message digest, the other side is clear text. Show IP OSPF neighbor. You can see the neighbor will go down. This will expire soon. 16, 14, 13, 11, 7, 6, 3, 1, go. Gone. Neighbor gone. Neighbor dead. Because one side is MD5, the other side is clear text. One side is type 1, the other side is type 2. How can we check that from the router? How can we check? How do we know the problem? How do we troubleshoot this? Debug IP OSPF adjacency. Adjacency will show you. Look at this. I want to stop the debug now. Look at this. It says mismatch authentication type. Type is mismatching. What we have is type 2. What we use is type 2. What we are receiving is input packet specified is type 1. Meaning router 2 is sending type 1, but we are using type 2. You can also see that in the Wireshark. You see, router 1 is sending cryptography type 2. And see, this is the password, Cisco 123. Can you guess? No, it's not possible to guess. Fully encrypted. Cryptography. Type 2 authentication. Whereas on router 2, it is simple password. It's plain password. Yeah. Now, what are we going to do? If you want the neighbor, we have to match on either side. So, go to router 2, enable Md5 authentication. Interface G1/0, IP OSPF authentication, message digest. Boom. This is going to bring the neighbor up. Look at this. Neighbor has come up. And now both the side is MD5. Earlier it was clear text from router 2, now it is hyper. You see? So we have got message digest on either side. That's how we got the neighbor. Is it clear for you? Is it easy? Did you understand?
Very much.
Alright.